This is the LeakSeeker 82B high definition version. We'll be showing you how it works in the standard 2-wire mode, which is how most people are going to be using it. On the PC board here, and this is just an old PC board from a Pioneer receiver, it could be anything. It could be a power supply, a VCR, it could be a computer motherboard, doesn't make any difference. As a technician, we've decided that there's a problem with the circuit that you see that's outlined in blue here. Why? Because if we go ahead and measure with our voltmeter on the ohm meter, you can see we have about a 3.6 ohm short. Now, we just know that LAN is not supposed to be shorted, at 3.6 ohms. It's supposed to be a power supply LAN that normally would measure several thousand ohms. And you can see where you go along that trace, it's the same 3.6 ohms. So clearly, even this $300 fluke meter can't tell the difference where the short is. It just knows that there's a short somewhere along that LAN. Now, LeakSeeker in its simplest mode, right now, 2-wire mode, push it to the 2-wire position, push the reset button once to let LeakSeeker know we're going to try to search for a short for the first time. You can use that reset button anytime you get confused. So it doesn't matter where we start. Now, I happen to know where the short is here, but you don't, so we're going to pretend to find it. And I don't really know where, so we're going to go ahead and we're just going to start anywhere. So we could start in this LAN, and LeakSeeker at this point has calibrated, and now you can see it's got a comfortable setting, and wherever it is doesn't make any difference. We're using comparisons. So as we go in this direction, we notice it's going higher in pitch. Now they are just recalibrated to a new window. Now what this is, it's a window. What that means is that the LeakSeeker's range is from 0 to 150 ohms, but the sensitivity is 20 milliohms, which would need about an 8-digit voltmeter or 8-digit dBm, obviously, to be able to read the difference. So what LeakSeeker is doing is chopping all those different resistances into windows, and each window is 20 milliohms. So it recalibrated to this particular window. See, it's already recalibrated to the next stop. We go back where we were, the reading is lower. If you go way back, there's no reading at all. LeakSeeker's already gone to the next window. So we're going to keep on going closer here, recalibrated. It's on a new window now. All right, if we go back, again, nothing. So it's on a new window. We're going to get closer here, higher pitch. But here it's maybe getting a little lower. I think it is. Let's keep on going. Now, clearly getting lower. Okay. It's like it just recalibrated. If we go back, no reading at all. We got a reading here. Nope. Very low here. That's clearly where the short is. And you can see, even though there's only a 1/4 inch of trace between here and here, you can tell by the lights and hear by the tone, there's a big difference. Well, if we go to the side, we're going to see that what we have is a diode with a 3.3 ohm short. You can see that I've simulated the short just by taking a good diode and putting a resistor across it. It's a very simple concept. LeakSeeker is measuring the micro difference in ohms from each pad, and it knows that whichever pad has a short on is going to be the lowest reading. And the reference to ground, which I just have soldered to this wire here, you can go anywhere along the ground here. Mathematically, if you do the math, you'll realize there's really no difference where you connect for ground. It's the active trace that's shorted that as you go pad hopping, that's going to tell you the difference. So that is LeakSeeker in the standard 2-wire test mode. Now, we're going to show how you use LeakSeeker in the high definition mode. Now, for example, we heard before that there's not a whole lot of difference here between these two. Well, say my hearing wasn't that good and I'm not really sure which the short is. Well, for example, I'm going to pull this up into the high definition mode, and looking at LeakSeeker, the offset control right now is pushed in, and you can see that it's in the automatic mode. And we're going to pull this out into the high definition mode. What that means is that it's locking the window, because we've gotten in the area that we know we want to probe further. By pulling that out, we lock the window so the automatic feature of going pad hopping or going from 20 milliohm window to the next 20 milliohm window, that's been turned off. It's locked in there, but it's also increased the sensitivity to 20 microohms. So now it's super sensitive. So I'm going to go right over here to this pad, and right now I'm not getting anything. I'm just going to adjust the offset so to be somewhere in the middle where I'm comfortable. So you can see the tone. Now listen to the difference. Look at that. Now it's a noticeable difference from this pad to this pad. We're not even going to get a reading here. So clearly, you can see that is a huge difference now, and that pad is only 1/4 inch. And that's a pretty wide pad, too. That's around probably a 30 mil pad. If you're doing a board that has much thinner traces, it's actually much more sensitive because those traces have much more resistance in them. The larger the trace, the harder it is to find. And as you can see, LeakSeeker found this. Well, again, I'm going slow to show you how it works, but I could have found this myself in about 10 seconds. And the only other method that you would have if you didn't have LeakSeeker would be to take a razor blade and cut the trace in various places and go with an ohm meter and see which is the one area that has the 3.6 ohm short. Obviously, you'd have a lot of repair work to do back on the board later on, or if you were the kind of person that would unsolder parts that you thought were bad, you could sit there and unsolder part after part after part with, doing all your guessing, and that could really take a long time versus with LeakSeeker. It's just a matter of just going pad hopping and listening to the beeps. So that was LeakSeeker in the standard 2-wire mode. In the automatic mode, where you sort going, chasing the resistance, and then you sort in high definition. So I'm going to start a new test now. I'm going to push to reset. So now what I'm going to do is something a little more difficult. If we test this bottom trace now, we were doing the top one at 3.6 ohms. If you look at the bottom trace now, and if you direct your attention to the DVM, you'll see that we're at about 47 ohms short. There's nothing else on the market that's going to find a 47 ohms short to ground, because no matter where you go with your meter, of course, you're going to show the same 47 ohms. As soon as we find the right line to go to. See, way over here it's 47 ohms, and you go over here, it's going to be the same 47 ohms, and so on. Now, LeakSeeker can go up to 150 ohms, so it's quite sensitive. So we push to reset, new test, and now we can start anywhere. It doesn't make any difference. I'm going to start, it doesn't matter. I guess I can start here. It's going to recalibrate, and now it's found a comfortable spot. Let's go in this direction. Nothing at all. So we know it's not that direction. Here's where we were. We're going to continue on. Okay, we're getting closer. Let it recalibrate. Okay, just found a new window. We go back now, no reading at all, where we just had a reading because it just went to a new window. So we're over here, go a little further. Okay, not there, but we're going in the right direction. Going in the right direction. Okay, going in the right direction. Okay, so we can see here is where the lowest reading is. See, there it's getting even lower. Here it's higher. There it's lower. Here it's higher. So we know that's the bad part. And if we go on the board, we'll see that that bad part happens to be a capacitor that I've soldered a 47 ohm resistor to simulate a capacitor that's partially shorted. Electrolytics pretty much short out anywhere from 0 up to 1 or 2 ohms usually. Tantalum capacitors can short up to around 100 ohms or so, so that's why LeakSeeker comes in handy. If this were a tantalum capacitor shorted at 47 ohms, nothing else on the planet is going to find it. LeakSeeker can find it.